When connecting a fire pump to an existing emergency generator, several factors beyond just using rigid galvanized conduit must be considered. Firstly, compliance with the latest edition of National Fire Protection Association 20 standard for the installation of stationary pumps for fire protection is essential. This standard provides comprehensive guidelines for the proper installation and operation of fire pumps. Secondly, ensure that the entire installation adheres to all applicable building, fire, and electrical codes. Local codes may have specific requirements that must be met to ensure safety and compliance. Thirdly, provide a dedicated fuel supply for the fire pump that is independent from the generator's fuel supply. This ensures that the fire pump has a reliable source of fuel, even if the generator's fuel supply is compromised. Fourthly, consider a separate fuel pump to supply fuel to the fire pump from the generator's fuel tank. This can improve the reliability and efficiency of the fuel supply system. Fifthly, perform fire pump endurance testing according to National Fire Protection Association 20 to demonstrate proper operation. This testing verifies that the fire pump can operate continuously for an extended period under simulated emergency conditions. Also, verify that the generator's electrical output is sufficient to power the fire pump and any other connected loads during an emergency. The generator must be capable of handling the fire pump's inrush current and continuous running current, as well as the demands of other essential equipment. Install an automatic transfer switch that automatically transfers power to the fire pump upon loss of normal power. The automatic transfer switch ensures that the fire pump receives power from the generator without any manual intervention. Use appropriate wiring and conduit for the fire pump circuit, considering voltage and current requirements. The wiring and conduit must be sized to handle the fire pump's electrical load and must be installed according to electrical codes. Provide a control panel for the generator and fire pump, including alarms and monitoring devices. The control panel allows for easy monitoring of the generator and fire pump status and provides alarms in case of any problems. Consider sound attenuation measures to mitigate noise from the generator. Generators can be noisy, so sound attenuation measures may be necessary to reduce noise pollution. Develop a comprehensive maintenance plan for the generator, fire pump, and associated equipment. Regular maintenance is essential to ensure that the generator and fire pump are always in good working order. Consult with the local fire marshal to ensure that the installation meets their requirements. The fire marshal may have specific requirements or recommendations for the installation. Inform building management about the installation and coordinate maintenance and emergency response procedures. Building management needs to be aware of the installation and how it affects the building's operations. While rigid galvanized conduit is commonly used, flexible conduit may be considered for portions of the installation where space constraints or vibration concerns exist. However, ensure that the flexible conduit meets all relevant codes and standards. Ensure proper ventilation for the generator room to prevent overheating and exhaust accumulation. Adequate ventilation is essential to prevent the generator from overheating and to remove exhaust fumes. The emergency generator needs to have adequate electrical output to power the fire pump. The generator needs to be sized appropriately based on the horsepower of the fire pump to ensure it can handle the load and the inrush current. For example, a 100 horsepower fire pump operating at 480 volts requires significant amperage. The generator needs to have a rating higher than that to accommodate other emergency loads. An automatic transfer switch is required to automatically switch from normal power to generator power in the event of a power outage. The transfer switch needs to be rated for the appropriate amperage and voltage and be listed for fire pump service. Wiring from the generator to the fire pump needs to be installed in appropriate conduit. Typically, rigid metal conduit is used for fire pump circuits to provide physical protection and maintain circuit integrity. The wire needs to be sized according to the National Electrical Code Table 310.16 based on the ampacity of the conductors and the overcurrent protection. A generator control panel is required to monitor the generator and fire pump status. The panel should include alarms for low fuel, over temperature, and other critical conditions. Sound attenuation may be necessary depending on the location of the generator. Generators can produce significant noise levels, and sound attenuation measures can help to reduce noise pollution. A maintenance plan is critical for the generator, fire pump, and transfer switch. Regular maintenance, including inspections, testing, and component replacement, is necessary to ensure reliable operation. Coordination with the local fire marshal is essential to ensure the installation meets their requirement. The fire marshal can provide guidance on local codes and standards and may require inspections and testing. Building management should be informed of the installation and the location of the equipment. They should also be trained on emergency procedures and how to operate the equipment. Flexible conduit may be considered in certain locations, such as connections to the fire pump motor, to reduce vibration and ease installation. However, flexible conduit must be listed and approved for the application. Adequate ventilation is required for the generator room to prevent overheating and the buildup of exhaust fumes. The ventilation system should be designed to provide adequate airflow and remove exhaust gases. Also consider fuel storage and fuel delivery systems. The generator needs an adequate fuel supply to run for the required duration of the fire pump, which can be several hours or even days depending on the application. Fuel tank needs to be sized accordingly, and the fuel delivery system needs to be reliable. Another consideration is remote monitoring and control. The generator and fire pump can be remotely monitored and controlled using a building automation system. This allows for remote start, stop, and monitoring of critical parameters. Another consideration is grounding and bonding. The generator, fire pump, and associated equipment need to be properly grounded and bonded to ensure safety and prevent electrical shock hazards. The grounding system needs to comply with the National Electrical Code Article 250. The fire pump controller needs to comply with National Fire Protection Association 20 and National Electrical Code Article 695. The controller needs to provide features such as automatic starting, manual starting, and overcurrent protection. The fire pump system needs to be tested regularly to ensure proper operation. Testing should include automatic starting, manual starting, and flow testing. The fire pump should be capable of providing the required flow and pressure for the fire protection system. When selecting a generator, consider the altitude. Generators direct at higher altitudes due to the thinner air. The generator needs to be sized accordingly based on the altitude of the installation. When selecting a generator, consider the ambient temperature. Generators also direct at higher ambient temperatures. The generator needs to be sized accordingly based on the ambient temperature of the installation. Also, consider the voltage regulation of the generator. The generator should have good voltage regulation to ensure that the fire pump operates properly. Poor voltage regulation can cause the fire pump to overheat and fail. Consider the frequency regulation of the generator. The generator should have good frequency regulation to ensure that the fire pump operates properly. Poor frequency regulation can cause the fire pump to operate erratically. Consider the harmonic distortion of the generator. The generator should have low harmonic distortion to prevent damage to the fire pump and other electrical equipment. High harmonic distortion can cause overheating and premature failure. Consider the transient response of the generator. The generator should have a good transient response to handle the inrush current of the fire pump. A poor transient response can cause the generator to stall or shut down. Consider the maintenance requirements of the generator. The generator should be easy to maintain and service. Regular maintenance is essential to ensure reliable operation. Consider the availability of spare parts for the generator. Spare parts should be readily available to minimize downtime in case of a breakdown. Consider the warranty of the generator. The generator should have a comprehensive warranty to protect against defects in materials and workmanship. Also, consider the reputation of the generator manufacturer. The generator manufacturer should have a good reputation for producing reliable and high-quality products. Consider the cost of the generator. The generator should be cost-effective considering its features, performance, and reliability. Consider the installation costs of the generator. The installation cost should be factored into the overall cost of the project. Consider the operating costs of the generator. The operating cost should include fuel consumption, maintenance, and repairs. Consider the environmental impact of the generator. The generator should meet all applicable environmental regulations. Consider the noise level of the generator. The generator should be as quiet as possible to minimize noise pollution. The location of the generator should be carefully considered. The generator should be located in a secure area that is protected from the elements. The generator should be easily accessible for maintenance and repairs. The generator should be located as close as possible to the fire pump to minimize voltage drop. The generator should be located away from any flammable materials. The generator should be located in an area with adequate ventilation. The generator should be located in an area that is not subject to flooding. The generator should be located in an area that is not subject to excessive vibration. The generator should be located in an area that is not subject to excessive dust. The generator should be located in an area that is not subject to excessive heat. The generator should be located in an area that is not subject to excessive cold. The generator should be located in an area that is not subject to excessive humidity. The generator should be located in an area that is not subject to corrosive fumes. The generator should be located in an area that is not subject to physical damage.